Right now, in the time it took you to blink, your phone sent and received over 10,000 pieces of data. Here's what's strange about that. Not a single piece of it traveled through anything you own. No company owns the internet, no government, no person. And yet it runs your bank, your job, your relationships, every single day. So who actually controls it? And what's stopping someone from just turning it off? By the end of this video, you'll know exactly what happens in the milliseconds between pressing enter and a website appearing on your screen. And you'll never look at your Wi-Fi router the same way again. There's also one part of this process, something happening every single time you go online, that most people find genuinely unsettling. We'll get there. Let's start with what the internet actually is. Because most people picture something abstract, a cloud, a signal in the air, magic. It's none of those things. The internet is physical. It's wires and cables and routers on telephone poles, buried underground, and stretched across the floors of entire oceans. Right now, there are cables running along the bottom of the Atlantic and Pacific, carrying data between continents at the speed of light. Your YouTube video, your bank transfer, your text message, all of it, at some point, is a pulse of light moving through a glass fiber thinner than a human hair. That's it. That's the internet. And as of 2025, over 6 billion people and 33 billion devices are connected to it simultaneously. Every single moment of every single day. So how does your device plug into all of that? Your home isn't connected directly to some master internet machine. It connects to a local network. That connects to a bigger network. That connects to an even bigger one. This is where the word internet actually comes from. Interconnected networks. It's not one thing. It's millions of networks, all agreeing to talk to each other. The bridge between your home and the rest of the world is your ISP, your Internet Service Provider. Companies like Comcast, AT&T, or Vodafone. They're the on-ramp. Without them, your home network is just an island. Now, once you're on the global network, how does your data know where to go? This is where IP addresses come in. Every device online, your phone, your laptop, your smart fridge, has a unique IP address. Think of it like a home address, but for machines. The problem is, those addresses are just numbers. Long, ugly strings of numbers. Nobody wants to type 142.250.80.46 every time they want to check their email. So we invented domain names. Google.com, YouTube.com. Simple, readable names that humans can actually remember. But your browser doesn't speak in domain names. It speaks in numbers. So something has to translate. That something is DNS, the domain name system, the internet's phone book. The moment you type a web address and hit enter, your browser quietly contacts a DNS server, asks, "What's the IP address for this domain?" Gets the answer, and heads to the right destination. All of that happens before a single piece of the website even starts loading. Here's a piece of internet history worth knowing. In 1969, the very first message ever sent over ARPANET, the military network that eventually became the internet, was supposed to be the word log in. The system crashed after 2 letters. The first ever message sent over what would become the internet was just LO. Poetic, honestly. Okay, so your browser knows where to go. But here's what most people don't realize about what happens next. The data doesn't travel as one big chunk. It gets broken apart. When you request a web page, that page is split into hundreds, sometimes thousands, of tiny pieces called packets. Each packet travels independently across the network, potentially taking a completely different route to reach you. and then they're all reassembled in the right order once they arrive. Think about the Statue of Liberty. It was built in France, disassembled into hundreds of individual pieces, shipped across the Atlantic in crates, and then reassembled in New York Harbor. That's literally how your data moves, every time you click anything. The system behind this is called TCP/IP. TCP breaks your data into packets and puts it back together correctly. IP routes each packet to the right destination. Together, they are the fundamental logic that makes the entire internet function. Without them, none of this works. Now pause, because this is the part I promised you. Every single time you go online, right now, as you're watching this, your data is passing through routers and servers you have zero control over. Machines in buildings you've never been to, owned by companies you've never heard of, in countries you may never visit. Which raises a real question. How does anyone keep any of this private? Or do they? We'll come back to that. But first, what's physically moving all of this? Routers. A router's job is straightforward. Look at a packet, figure out the best path forward, send it there. They're the traffic cops of the internet, constantly making split-second decisions billions of times a day. Switches do something similar, but on a smaller scale, connecting devices within a single local network. And at the end of all those routes? Servers. Web servers are just computers, powerful ones, that store websites and send them to you when you ask. And the cloud everyone talks about? Not mysterious, not floating anywhere. It's warehouses. Massive buildings packed floor to ceiling with servers, running 24 hours a day, cooled by industrial air systems, backed by their own power generators. Google has them. Amazon has them. Microsoft has them. When you save a photo to the cloud, you are literally putting it in a building somewhere. It's on a physical hard drive, in a physical rack, in a physical room. That's the cloud. Now let's put it all together. One click. Here's exactly what happens. You type a URL and hit enter. Your browser contacts a DNS server and gets the IP address for that website. Your browser sends an HTTP request, essentially a message that says, "Send me this page," to the server at that address. Before any data even starts moving, two handshakes happen. A TCP handshake to establish the connection, a TLS handshake to encrypt it so nobody can read it in transit. That's the answer to the privacy question, by the way, and it's imperfect, but it's what's standing between your data and everyone it passes through. Then the server responds, breaking the page into packets. Those packets travel through routers, potentially dozens of them, across multiple countries, before reaching your device. Your browser reassembles them in the correct order and renders the page. The whole thing, DNS lookup, handshakes, data transfer, reassembly, typically completes in under a second. Every single click. The internet isn't magic. It's millions of physical machines, invisible agreements, and split-second decisions working in perfect synchronization, billions of times a day. The fact that it works, that you can pull up any piece of information from anywhere in the world in less time than it takes to snap your fingers, is one of the greatest engineering achievements in human history. But here's what we didn't get into today. What happens when it breaks? When an undersea cable gets severed, when a DNS server goes down, when a major router fails, and the small group of people responsible for fixing it. That's a whole other story, and it's the next video. If this made you think differently about your Wi-Fi router, subscribe. Every week we break down the technology running your world in plain English. See you next time.